PV array has S1 shading attribute to the IV curve denotes the let's go to the PV curve. You can see it's the string number one. With module layout will take some, so we energy management. Just Assalamu alaikum, welcome back to our fifth video of PVsyst simulation series. So for till now we have discussed about the orientation system, detail losses, self-consumption or storage and optionals, uh, what is horizon, what is near shading. Now let's move towards the module layout. So let's click on the module layout option. So you can see that we have table choice in 3D. So let's maximize it and let's select randomly tables and column. From here you can see the position in ML is changing as per our requirement. Like I just click on this module and you can see that it is denoting that it is row number 15 and column number 7. Okay, let's set all modules. So I have to it's in mechanical module. Let's set all module in its electrical fields. So let's go to the electrical fields and it's string 1, it's string 2, it's string 3, 4, 5, 6, 7, 8, 9, 10. 10 strings are connected in inverter number 1, which is PV arrays. And now inverter number 2, PV array, has S1, S11 to S12, which is also 10 strings which are being connected. And these are the number of panels: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 panels are in series which are connected in series which is connected to the MPDs of the inverter. Now this submodule function bypass diode arrangement half-cal cell even module. So we will auto attribute it, and now we are going to distribute all. So here we have distributed them according to the depending upon their colors. Distribution selection. Now it's fine. Let's close it, and we have done with the module layout, ready for the electrical shading calculation. Now you can use the shading 3D. Let's use the 3D shading attribute to calculate its shading effect. So let's close it. So I'm going to use today's date to calculate it. Now let's calculate it according to July 17 July. Let's do this. As you see, it is calculating the shading animation, which we have drawn the sketcher file and uploaded it on our PVsyst module on the basis of this. So incident global 18 watt per meter and sun height is 3.6 degree, diffuse 10 watt per meter square. Clear dim, it's a clear dim model, and sun horizon is 122 degrees centigrade, 0.60. Shading loss on a clear beam linear loss is 0.0, electrical loss is 0.1%, which includes various factors like resistance of the wires, etc. Show relative losses. No show shading for the, yeah. Now let's go to the today's, yeah, let's calculate this. So here you can see that the linear loss is 0.1%, electrical loss is 0.2% for this timeline. Meanwhile, we have a result. Beam linear loss is 0.1% and electrical loss is around 0.3%. So you can also see from this we have changing the azimuth. Okay, now let's see the IV curve. Okay, so the IV curve denotes the systems parameters. It's the inverter number 1, which have the string 1 to 10. It's let's see, it's a string 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So different colors are denoting different things. Let's find out what they are representing us. So it's string number 11 to 12. It's denoted like this. Let's stay on this numerator number 1. So we have number of 10 and string module in series is 18. So panel irradiation is this and beam, and which the this inverter has 0.7% shading effect irradiation, and the other one has 0.0% because maybe those panels are beyond the shading. So let's have the according to linear shade calculation according to shaded corners. Yeah, it will be fast. Let's geometric calculation. Let's do it with the geometric calculation, which will be which will give a better result. So it's saying the P maximum is 53 kilowatt. It's P 53 irradiation 0.6 per electrical loss 0.0%. Okay, let's go to the PV curve. Okay, so it's ampere and its voltage. So it's basically, sorry, it's basically IV curve, and this was the power and voltage curve. Okay, so you can see the power, it rises from this one, it is going to this thing, and it is going to back. PV curve for clear condition is radius is 530 watt per meter square, which is enough for me, but I don't know about your side. Maybe it will be various or according to your side data and side thing. So let's open the 3D scene and see our module. Yeah, here you can see it's the string number 1, it is the string number 2, 3, 4, 5, 6, 7, 8, it's 9, and it's the 10th one string. Now it's the 11th one, it is the 12th one, it's a 13, it's a 14, the yellow one, and the 15, 16, and so on, it is going on. Okay, so different colors are denoting the different strings in it. So I'm just going to close it and just clicking OK. All the things are done here. No, I don't need to do anything here. Electrical shading, electrical, yeah, I don't have to do anything right now. So we have done with it with module layout. Now let's save this file, save it. Let's recheck this again. Yeah, we have done with it, and I have done with it too, with it too, with it too, with it too. Yeah, okay, now we are going to the energy management. So energy management, let's inverter temperature, external inverter without my basically you have to select according this according to your requirement. Like in my case, my inverter is hanging outside the building, or I can say it is hanging in the outside on the wall. So external ambient temperature, it's outdoor installation. Okay, or indoor. If it is indoor, you can use external ambient temperature with shift or fixed temperature indoor. Okay, so I'm using the by default external ambient temperature. Now we are going to use the power factor. Use power factor for grid injector. In my case, it is 0.98. Okay, it is leading and lagging both. Okay, so you can also define values per month, but I'm not going to this. Limited force as a parent power limited. No, I'm not going to use these things. Grid power limitation. If you have any grid power limitation, you can add these limitation to this. Actual install AC power is 200 and nominal LAPV is 208. Grid power limited area power, you can account as separate loss, you can count this, but in my case I'm not going to use this thing. Grid power limitation, now I'm not going to use this thing. Now let's go to the P15 and P90 estimation. Basically, these P50 and P90 is represent to the probability. So, sorry, my mistake. Data source is from this and kind of data not defined. Let's define it. Monthly average is climate change. Let's have a 2% and annual variability is minus 0.5%, or no, it might be 4.6%, which is by default. PV module modeling is 1%. Okay, soiling mismatch, degradation, custom variability is 1%. Show PMAX on report on main result page. No, it will be show PV on report. It will be better for me. And yeah, it is good for me. Let's system check the system overview. It will take some time to load everything, so we have to wait a little bit, a couple of minutes. So we have the summaries of our system, and here we go. Linear using simulation linear irradiation defect. So it is great till now. Energy management. Oops, sorry, I have to just now I have to save it, and here we go. So so far so good. We can discuss the things, other things in our next video. Till then, take care. Allah Hafiz.